Have you ever turned on the water in your house and wondered why the water comes out so much faster in one sink than in another? Or whenever you're taking a shower and the water pressure is so much better in one shower compared to the other? Well, there's actually a reason for this, and this reason is largely due to head loss. Head loss is the energy reduction due to friction in pipe flow, and we can demonstrate this with a model. Okay, so let's assume the direction of flow first. This being, let's assume the water pipe runs from the main to the back of the apartment and my bathroom first. So the water goes from here to the back of the apartment, and let's call this point 1. And then proceeds to the kitchen, to my faucet here at point 2. So we have our height Z1, and we'll call this Z2. And then we have a pressure at point 2 and point 1. And then the speed at which the water comes out, we'll call this V1 and V2. Okay, and so with our 6 variables, we can use Bernoulli's equation in order to find our unknown head loss. We have our pressure at point 1 and point 2, which is actually just our atmospheric pressure. We have our heights, Z1 and Z2, and then we have our velocities, V1 and V2. Our velocities can actually be found by measuring the flow rate of filling up a volumetric device over a given amount of time. So if we find, say, a given volume and divided by the time it takes to fill up, we can get our flow rate. Okay, so here we are in my kitchen. I have a Tupperware container that I pre-measured up to 32 fluid ounces. And then I have a timer. And so let's calculate the flow rate. So there we are at 25.91 seconds. Okay, and here we are in my bathroom. Now let's calculate the other flow rate. Okay, this one we got 11.66 seconds. Okay, and now let's calculate the value of our heights with my makeshift ruler.
Student life is rough.
Okay, so we have our height value. And now let's calculate the height for our second sink. Alright, and so we have our second height.
So area is just pi r squared, so all we really need to do is find the radius.
Okay, so now we have indeed found everything. We found our heights, Z2, Z1. We found our volume, our time, our radiuses. But also notice that I converted everything to SI units. I converted my 32 fluid ounces to meters cubed. I converted my centimeters to meters. And now let's find our velocity. So if velocity is our flow rate over our area, and our flow rate is our volume over our time, our velocity thus equals our volume over our area over our time, where area is pi r squared times our time. Okay, so for our V1 we have 0.02 squared times pi times 11.66 seconds, all divided by, thus our first velocity is 0.0646 meters per second. And for our second velocity, we have 0.02 squared times pi times 25.91, all under 9. As our second velocity is 0.029 meters per second. Okay, and now all there's left to do is just plug our values into Bernoulli's equation. But an interesting note is we can actually prove our assumption. So whether my assumption was correct that our flow goes from the bathroom to the kitchen, if our head loss is greater than 0, that will indeed be correct. But if my assumption is wrong, our head loss will actually be less than 0. So let's go ahead and plug everything in. So for P1, we just have our atmospheric pressure over our specific gravity plus our first velocity, 0.0646 squared divided by 2 times gravity, plus our first height, 0.85 meters, equals, again, for P2 is also our atmospheric pressure divided by specific gravity, plus V2, which is 0.029 squared, 2g, plus our final height, which is 1.06 meters, plus our unknown value, which is our head loss. Okay, so we have just about found our head loss. Here we can cancel out our atmospheric pressures, given they're same. And here I have calculated our velocity components and just added them together, just to show here that it's almost trivial that them added together is a marginal amount compared to the height here. So in order to find our overall head loss, we just 0.5 plus 0.017 minus 1.06 equals. So, as you can see here, I was indeed wrong about our direction of flow. Our head loss is in fact less than 0, so it turns out our flow actually goes from our kitchen to our bathroom and not the other way around.